All right, guys, in this video, we're going to continue on after the lab fortified blank, and the next definitions that we're going to hit are 310 and 311. 310 is a stock standard solution, and 311 is a primary dilution standard, also abbreviated as SSS and PDS. All these abbreviations, that's all the quality is about, abbreviation, abbreviation, abbreviation. You know that there's going to be a quiz question, by the way. You know that there's going to be some matching, or tell me what this abbreviation stands for, so you might as well get ready for it. So 310 and 311, what are the differences? Because both of these say standard, standard. Again, there's more confusion here, I think, and the reason is the word primary. 311 says primary dilution standard. The key word, though, in that is dilution, not primary, and I think that's the word that throws people off. The word primary means first, or you should give preference to it. However, that's not really what these standards are, and the reason that I say that, I'll tell you, okay? So in order to do that, though, I'm going to give you Tracy definitions of each of these. But 310 says a standard stock solution, SSS, a concentrated solution containing one or more method analytes prepared in the lab using assayed reference materials or purchased from a reputable commercial source. And then 311 says a solution of several analytes that are prepared in a lab from stock standard solutions, and they are diluted as needed to prepare the calibration solutions and others that are needed for the analytes. All right, so let me just sum this up maybe in an easy way for you. And I'm going to go back to this idea of our iron in the cereal example. So let's say that I am wanting to find the iron content in cereal. Again, it's fortified. They're adding iron content in. It's a vitamin. I want to make sure that they're adding the appropriate amount, and what shows up on the nutrition label is what should be there. So that probably means that at some point in time, I'm going to have to get my hands on something that we call a standard. And we've referenced standards before, and standards have been used to make calibration curves, right? Okay, so the standard would be a solution that has been prepped either by me or from another company. And this could be like a really strong concentration of iron. So iron that's already in solution, maybe it's 1,000 part per million, right? Just gives me a concentration to go by, and I can order it. All right, that's the thing. I can order these. Someone has made it, someone has tested it, and someone has given me a piece of paper, and that piece of paper says, yes, we've tested, and here are our results, and we feel really good about our lab data. Here's our average, and here's our standard deviation, and here's our percent RSD, and here's our 95% confidence level. We are 95% sure that the true value of this standard that you have ordered falls in the realm of 998 to 1002. Okay, well, thank you, third-party company. Thank you, Fisher Scientific. Thank you, VWR, for giving me that information. All right, so I take this into a laboratory and I have it on the lab shelf. Now, if I didn't want to order it, the method does say I could make it. But in order to make it, you have to have assayed materials. I mean, right? I mean, that's what it said. So if I go back to this method, and I take a look at this word, assayed reference materials, that just means the percent purity has been documented and reported. That's what that means. So if I do have to make it from scratch, I'm going to use some type of iron compound probably that has a percent purity assigned to it, and I know what I'm using, the purity of that, and hopefully it's really close to 100%. It will never be 100%, but hopefully it'll be really close to 100%. All right, so that is the story with what we would call a stock standard solution. This is my SSS. That's what that refers to, okay? Something that I have made with a very high purity substance, or something that I have ordered that is already in the lab, ready to go, and someone else has already checked it. That is the stock standard solutions. It is stock because this is on the lab shelf and we can use it multiple times throughout the day or throughout the weeks. As long as the expiration date has not expired, then I am free to use the standard stock solution or the stock standard solution in order for this process to work out the proper way. All right, so certified material, very clean, very high purity. I've ordered it, it's ready to go, and then from here, we make everything else. That's the key. So the SSSs, the stock standards, are used to make all of the other standards concerning iron in this case, all of the other standards in the lab. All right, so what would happen is that maybe the SOP is going to give me some directions. And the SOP says, from your stock standard solution, ding, 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 ding. That's what that means. From the stock standard solution, take, I don't know, 10 milliliters of that material and dilute it to a total of 100 milliliters in a volumetric flask. All right, this is a prep step. That's what this is. So the SSS is going to get used, and it's going to prepare another standard, because this is still a standard. And the reason that I call this a standard is because it's just really my solvent, whatever the solvent might be, and iron. There's nothing else in it. There's no other analytes. There's no matrix. Nothing else. Nothing interfering. Just solvent and Fe. That's what it is. Okay. So if I make that sample, I have just basically diluted it. I have a really strong sample up here, concentration-wise, 1,000 ppm. And 1,000 ppm is often too strong. Way too strong to do things with. We work much lower concentrations than that. And keep in mind, 1,000 part per million, that means 1,000 milligrams per liter of solution. I mean, that's quite a bit, right? So 1,000 milligrams in 1 liter dissolved is way too strong for our instrumentation, most likely in an analytical lab. So we have to dilute it, and the SOP is going to tell me how to dilute this down. And maybe it says take 10 milliliters of that using a volumetric pipette, deliver 10 milliliters into a volumetric flask, and dilute to the line with solvent. And they'll put in parentheses water. Okay, whatever. Simple, easy. We've done that in one of our lab experiments, right? We had blue solutions. You diluted some of it, made them weaker, weaker, weaker. Okay. Well, that blue solution that you used in the very beginning, that was maybe our stock standard solution. That was a little tiny jar. It had the most concentrated solution in it. You grabbed a hold of it, and you used that to make other things with. Okay, that's way too strong. We had to dilute it down. Maybe Kim did this for you, right? Maybe Kim took a stronger solution, diluted it down, and put them in little bottles to give to you. Well, what did she do if she did prep it that way? If she did dilute this down, this is what we would call the primary dilution standard. And now you see why we call it this. Primary means the first. This is the first dilution. That's the key word. Primary is not the key word. Dilution is the key word. This is the first dilution step that has been made. And what happens is that we've made it weaker. That 1,000 ppm now has gotten a little bit weaker in order for us to do something with. But maybe this is still too strong, and that is the case sometimes, right? So this is often kind of like the middle step. Too strong, can't run it, still can't run it. So then maybe the SOP is going to give you directions, and then it's going to say, using the primary dilution standards, make calibration 1, calibration 2, calibration 3, calibration 4, and calibration 5. Thank you, and this is what you're going to build your calibration curve against. Those are our cal standards, CAL. That is what that represents. So the standard stock solution or stock standard solution, this is the original. We ordered it very high purity. We get it into our lab. That is way too strong for almost everything. And then we take some of that and dilute it down, make it weaker, but it's still too strong. So that is our primary dilution standard, our PDS. And then the primary dilution standard will be used to make all of our calibration standards that we need for a laboratory procedure. Okay? Now, I know what you're thinking. Because, trust me, I do the same thing. Why? Why do we do this like middle step here? Why don't we go with 1,000 ppm and just go all the way down to the calibration standards and skip that whole sample prep? You could. No one says that you can't. But you have to make sure that the concentrations down here are appropriate. And you have to make sure that these are not very tiny volumes. Because if they are, let's say that this ends up being like 10 microliters of solution, that like really weirds people out. Oh my God. Think about the micropipetting lab. Oh my God, 10 microliters? You want me to deliver 10 microliters and maybe go even smaller than 10 microliters to get to that end result down there at the bottom? There's no way. I'm not going to do that and feel really good about it. 10 microliters were probably your biggest errors on the spreadsheets when we did that lab, right? So could you imagine little bitty tiny fractions of a droplet getting added to a calibration standard? There's no way that I'm going to prep that and feel good about it and get a really good curve. So what happens here is that a middle step is often needed. So that way we can take this super strong thing and weaken it down. I mean, that's the whole purpose of this. We weaken it down to a point where, okay, now we can prep everything else. And we might not need 10 microliters anymore. We now can go to a milliliter and 0.75 milliliters and 0.500 milliliters. Maybe that's going to be a little bit better than working with these really tiny volumes in the end. Nobody wants to do that, right? And the smaller we go, the more chances of error that gets built into the system. And without a proper calibration curve, folks, you can't do anything. There's no quantitative work that can go in to running a batch of samples. So the calibration curve is very, very important. Without that curve being proper, nothing else can get done. So we don't want to take any chances. So if we can make a dilution scheme that takes something really strong and makes it a little bit weaker, and then use that to make everything else with, that's exactly what we're going to do, because it gives us volumes that are workable. It doesn't give us volumes where we're crossing our fingers and gritting our teeth and saying, I hope he doesn't say that my error is too big and I have to go back and remake it because nobody else wants to do that, right? So this is the summary of SSS and PDS, our stock standard solution and our primary dilution standard. So stock standard typically has been purchased. That is the key. We do. We purchase all of those, and that's what we use to make everything else with. So it comes with a piece of paper, and that piece of paper is going to say, yep, it's been certified. It is accurate. Ding, ding, ding. Here you go. That's an abbreviation that we've already learned maybe, right? So this is going to be used to make the primary standard solution. Now, I said primary diluted solution or primary diluted standard. It goes by different names depending on the methods that you're using. If I go here to the EPA, this says primary dilution standard solution. So they do use the word dilution in here, but some people do not. And what you're seeing on the PowerPoint right now, EPA has inserted the word dilution in between primary and standard, just to drive home that this has been diluted from something else, right? I mean, that's the whole key with that. So I like the EPA for that reason. They make this maybe a little bit easier of judgment call on what they're really referring to here. So primary dilution or primary diluted means I've taken something, diluted it to get to this point first. Okay. Other methods, though, they just skip the word diluted and they use primary standard. Okay, that might not be referring to the stock standard. It could, it might not be, but that's a part of the method and that's part of the SOP. All right, so primary standard solutions or primary diluted standard solutions are taken from the stock standard. So we've weakened it, and we've weakened it to make like a middleman solution or middle woman solution. I don't want to play gender role here, right? So middle man or middle woman, this is what's going to be used to make everything else with. So it's a good starting place. We've made it weaker, but not weak enough. And then everything else is going to be made from the PDS, the primary dilution standard. And these are called working standards most of the time, abbreviated as CAL. So this is what actually gets ran. It's what actually gets seen by the machines. It's what shows up on our reports. That's why we call them the working standards, because they're doing a job, and that job is to run, get analyzed, give us some data, so that way we can build a calibration curve around those. So the working standard solutions are also called the CAL solutions. That's what those are. Okay. All right. So that's kind of the thing here. Now, weird things about the definitions. What if you don't need to go to a middleman? That's fine. You can make the calibration standards directly from the stock. No one says that you can't, but that depends on the method and that depends on the SOP. Very often, though, these are too strong and we do have to weaken them down first. But no one says you can't start from the stock and work from there. That's perfectly okay if that's allowed and if it makes sense, okay? Next up, what if the primary really is too strong again and we've got to weaken it down one more time? That's okay. No one says you can't do it. But what is that called? That would be first formally called the working standard. And that working standard will then get diluted down again to make the calibration standard. So we're back in the same discussion. We're back in the same definition. Maybe you don't need a proper working standard or another dilution. If not, that's okay. No one says that you have to. No one says that you can't have one. So we give you these directions. We give you these definitions. This is our primary. This is what we're going to make every other calibration curve with, standard-wise. That's perfectly fine. But there could be extras that get into this mix as well. And I don't want you to be surprised with that if that goes on. So the SOP is going to tell you that information. They will define that the way that they want to define it. Meaning they're letting the laboratory make that decision. So if they start with a stock, that's fine, SSS. They make a primary diluted standard. That's fine. That's our PDS. Maybe that's too strong though, right? Maybe we've got to weaken it down again. So if we weaken it down one more time, we can use working standard for that. We can define that the way that we want to define it. We can put a number or a letter code on it or some type of abbreviation. It doesn't really matter. But then that one that's even weaker now can be used to make all of our other CAL solutions with. So whatever works for the lab, they've got the freedom to make those judgment calls and those changes whenever they want. All right. Again, if I kind of had to sum it up just in a different way, we get a standard that is ordered and the standard we dilute, and that primary standard now, the diluted standard, is what's on our shelf. We make this weaker, and that weaker one could maybe make a working standard that we can then make all of our standards from. That is perfectly okay. It's another option, right? Because the primary dilution might be too strong. And if so, that's fine. We weaken it down until we get to a point that's workable and manageable. So if we've got to make it weaker again, that's okay. But some people might call that the working standard now. And that one will make all of our cal curves. All right. If this is not needed, then the primary dilution standard will be used directly to make all of these calibration solutions with. They might call these the working standards. They might call these the cal standards. Whatever the case is, they make that judgment call. But this middle step here, or actually third step, is maybe not needed every time. And if not, that's perfectly fine. That is built in the SOP, and that's its rhyme, that's its purpose, that's its reason. All right. So we're almost done with definitions, and in the next one we have a quality control sample. So I'll talk about this in the next video, and that will finish up our definition section, and then we'll venture on into the other areas of the SOP that maybe we want to highlight or talk about.